In this last example, which is a good one, we're going to combine basically both types of probabilities we were calculating, right? Our disjoint or overlapping situation, right? The or, as well as what we talked about in the previous lesson, which was the and, right? The independent or dependent situation. And rather than worrying about, wait, is this independent, dependent, or whatever, I think it actually makes a lot more sense once we really understand what's going on, to draw the tree diagram, to visualize all the different paths and all the different outcomes, and then we can basically read the tree to calculate our probability, which will make it nice and easy once we get there. So I think the difficult part to this is really just understanding what the tree was going to be. So let's take our time, read through the example, and try to really dive into what it's asking us to do. So a medical association estimates that 10.9% of the people in the US have a thyroid disorder. Suppose a medical lab has developed a simple diagnostic test that is 96% accurate for people who have the disorder and 99% accurate for people who do not have it. The medical lab gives the test to a randomly selected person. What's the probability that the diagnosis is correct? So before we just dive into this and say, well, isn't it, 96% accurate? Wait, it could also be 99% accurate. Is it both of those? Well, that's where we have to actually look at how do we know if it's correct, right? So we actually have two different outcomes if it's correct, right? We could either, right, have the disorder and test positive, right? Or you don't have the disorder and you test negative. So there's basically two situations we have to look at. Does the person actually have the disorder or not? And then how does the test come out? And let me just rewrite that because that's a little hard to read. There you go, that's a little better. So again, two things, right? Either you've got the disorder or you don't. Even if you don't take the test, you either have it or you don't, right? Just because you don't take the test doesn't mean something, doesn't happen, or it's not true about your own health, right? Either you have it or you don't, even if you don't know. And then our test, once you take it, tells you one of two things. We test positive or we're going to test negative. And we can combine this, right? You could have the disorder and the test fails you and you test negative. You can have disorder and it tests positive. You can have no disorder, test negative, or it could mess up and you could have no disorder, but it has a false positive. So that's what we want to actually do in our tree. So where do we begin? Well, let's start with all the people, right? Because if we look at the very first sentence, a medical association estimates that 10.9% of all of our people in the US, the population of the US, has a thyroid disorder. So we're going to start with all of our people, right? So the population of the United States. Now, of all those people, 10.9% of them have a disorder, according to this estimate. So yes, they have a disorder. Whether or not they get the test, whether or not they know it, the estimate is 10.9% of them have it. I'm going to convert that to a decimal, but you can leave it as a percent if you'd like. But we know 0.109 or 10.9% of the entire population has a disorder. So what does that mean about the people who don't have a disorder? Well, this is where the complement comes in, right? If 10.9% of them have disorder, the remaining 89.1% don't, because you either have it or you don't. There's no in between, right? You can't kind of have disorder but kind of not have the disorder. It's either one or the other, not both, which is why we can use the complement. So that means I'm going to convert this again to a decimal. 0.891 or 89.1% of our population has no disorder or no thyroid disorder. So again, I'm not writing thyroid disorder. Well, maybe I should. Let me add that in to make it clear, because we want to be specific here about the thyroid disorder. There we go, just to be clear, because you can not have a thyroid disorder but have a, heart disorder or some other kind of condition. But anyway, so again, for this specific thyroid disorder, 10.9% of the population, whether or not they get a test, whether or not they know it, have it. 89.1 do not. Again, whether they know it or not, different story. So now we've split our population to two groups, right? You either have it or you don't. And now among the people who get tested, right, you have two possible outcomes. You could have the disorder, take the test, and you test positive. You can have the disorder, take the test, but test negative. Same on the other side, right? You can have no disorder, test positive, and that would be a false positive, right? You can have no disorder and get the correct results back and test negative. So now how do we figure out the probabilities or the percentages for that? Well, if we go back and look at the directions again, it's telling us that 96% accuracy rate for people who have the disorder. So if you have the disorder here, right, 96% chance it's going to tell you, yes, you are positive. So that means here, 0.96, because I'm converting everything to decimals. If you have the disorder and you take this test, you have a 96% chance of getting a positive result, which means it does test correctly. So then what does that mean for the negative? Well, remember these two, positive, negative, has to add up to 1 because you're either going to get a positive or a negative result from this test. So that means 4% or 0.04 are going to get the negative, and that would be an incorrect diagnosis, right? Same thing if we look at the last percentage. Now it's telling us there's a 99% accuracy rate for people who do not have it. So now if we look at the other side, you don't have a thyroid disorder and you took this test. You have a 99% chance or 0.99, right, chance of getting let me back up. If it's accurate for no disorder, then you should have a 99% chance or 0.99 probability of testing negative because it should give you a correct diagnosis. So we want to be careful there. A lot of people did what I just did earlier and would put, okay, well, correct is positive, so I'm going to put it on the positive side. But no, if you don't have a disorder, you want your test to come out negative because that is the true diagnosis, right? Which means you have a 1% chance of testing positive, which would incorrectly tell us we have something wrong with our thyroid when it doesn't. So that is the actual picture of the whole situation here, okay? So how do we figure out the probability? Well, once you get your tree diagram, what you want to do is you want to figure out what are the paths that lead us to the correct diagnosis. And those paths are what I detailed right up here, right? We want to either, yes, have the disorder and test positive, which means, okay, this person's got a thyroid disorder and they tested positive, or we want to say, okay, for someone who doesn't have a disorder, it's got to tell us, no, we don't have a disorder. We've got to test negative. So I've highlighted the two pathways to give us the correct diagnosis because there's two correct diagnoses. And then how do we find this probability? Well, you can look at this as a combination of a dependent event and a disjoint event. If that sounds really complicated, let me just walk you through. So we have either you can be have a thyroid disorder and test positive, or you can have no thyroid disorder and test negative. So let me just use letters here to kind of break up what, so I don't have to write everything again. So I'm going to call A thyroid disorder. So not A is no thyroid disorder. B is a positive test result. Negative is not B. So what we're doing here is I'm just going to rewrite this. We said we have the probability of getting a correct diagnosis is two possible paths. It's either the probability that we have a thyroid disorder, which is A, and B, so you have the disorder and you test positive, or it's the probability, we're going to find the probability of no thyroid disorder, which is not A, and not B. So you can see the and is the kind of compound situation, right? And here it's going to be dependent because the test depends on whether or not the test accuracy depends on whether or not you have the disorder. And then the or is what we were just talking about when we are looking at overlapping or disjoint. And in this situation, there's no overlapping because there's no way you can have both a thyroid disorder and no thyroid disorder at the same time. And your test can't both be positive and negative at the same time. So that's what I meant by it is dependent and disjoint. But what you have to remember is simply this. When we have and, we're going to multiply. When we have or, we're going to add. And you can see that corresponds with the tree. We're going to multiply the individual values along the path, so 0.109 times 0.96. Separately, we're going to multiply 0.891 times 0.99, and then we're going to add the two together. And that's how we kind of combine these two types of events. Okay, so again, I'm going to multiply. So what is the probability of A and B? Well, that is that 0.109 times 0.96, which is just multiplying, yes, I have a thyroid disorder, and yes, I tested positive. Then I'm going to add that to the second branch, right? The second path, which is 0.891 times 0.99, or no, I didn't have the disorder, and no, I did not test positive. And then we're just going to add those together. So that's going to be 0.10464 plus 0.88209, which will give us 0.98673, or 98.673%. Okay, obviously depending on the question, if it asks you to round, please do round. But with these problems, once you get the tree and you get your different end points, right, it's pretty straightforward. You're going to multiply the branches together, add the different paths. And when I talk about the branches, it's like what I'm talking about right here, right? The branch going to the thyroid disorder and this branch of positive, we multiply them together, then we multiply these two branches together, and we're adding the two total paths. And that's why I do like the tree diagram for this, because it helps me visualize what I'm doing. But making that tree diagram is definitely a difficult part. So don't be afraid to ask questions if you get stuck. But please do practice these, because this is where you see everything kind of come together, and it allows us to use probability with bigger problems and more. It's a more practical application of probability, because not everything's going to be one or the other, or one and the other. It's often a combination of multiple things. All right, thank you for listening.